Hi class, today I'm going to do a quick video on significant figures. Significant figures are important when taking measurements in chemistry and physics, and it shows the relevant numbers that are important in your calculations. There are four rules to remember when determining your significant figures. Now, the reason why we use it, again, we can read lab instruments and perform calculations with the correct degree of precision. Precision shows how close your data is to each other. Rule 1, non-zero digits like 1 through 9 and zeros between two digits are always significant. For instance, 4893 will all be sig fig. 9, these zeros in between the 6 would also be significant figures. Number 2, leading zeros in front of the number are not significant. 0.00052, the zeros would not be sig fig. The 5 and the 2 would be. Now, zeros to the right of non-zero digits are only significant if you have your decimal point. In this number, all the zeros to the right would be a sig fig. Finally, for all values in scientific notation, the digits in the coefficient would be significant. So 3.56 times 10 to the 7th, you don't worry about the 10 to the 7th, it's just 3.56 would be significant. You have all of these rules on your chemistry and physics reference materials. It's on the bottom of page 2. So you don't have to memorize these rules, you just need to know how to use them in examples. Here's an easy way to remember the rules for sig figs. Let's draw a map of the USA. I know my state of Texas is a little off here. In the USA, you have two oceans. On the left, you have your Pacific Ocean, and on the right, you have your Atlantic Ocean. Now imagine in the Pacific Ocean having a big buoy that's bobbing up and down in the water. This buoy will represent a decimal point. Okay? Now, whenever you have a decimal point, you're going to start in the Pacific on the left, and then you're going to head towards the Atlantic on the right. If there's no decimal point, like in the Atlantic, you go to the right towards the Pacific. And then you always count the first non-zero number. So 1 through 9. And then every number afterwards would be significant. Alright, let's try some examples for using the Atlantic Pacific rule for sig figs. If we have 4.58, again, you have a decimal point, so that means you start at the Pacific, left to right. All these are non-zero, you'd have 3 sig figs. If we have the number 2.03, again, decimal point means left to right. The 2 is the first sig fig, everything else counts, including the 0, so that's 3 also. What if we have a number like 0.04? In this case, again, decimal point left to right. This 0 and the 0 won't count though. You have to count the first non-zero, so the 4 would be the only sig fig. Some examples without a decimal point. Let's say we have 502. No decimal point means you count from right to left. The 2 is the first non-zero, everything else will count. Here you would have 3 sig figs. If I have the number, say, 400, with no decimal point, I count right to left, these zeros wouldn't count, but the 4 would. So here I have 1 sig fig. However, if I wrote it as 400 with a decimal point means Pacific. You'd count right to left. 4 would be the first number, everything else counts. So here you have 3 sig figs. The only difference with the decimal point or not means that you measured it. So you might have an accurate measurement and it, say it weighed 400 grams, then you'd have a decimal point. Here are your rules for adding and subtracting significant figures. The answer may only contain as many decimal places as the measurement with the least number of decimals. For instance, 3.75 plus 4.1, you want to put that in your calculator first, you'd get 7.85 milliliters. Now the sig figs, 4.1 only has 1 digit to the right of the decimal. So that's going to be what your answer needs to be. For 7.85, you're going to start at 7.8. The next number is for rounding. If this number is 5 or bigger, then you're going to go up 1. So since it's a 5, you're going to go 7.9, 1 bigger than 8. If it was 1 to 4, like 7.84, then you just keep it as 7.8. Next, for multiplying and dividing, you're going to count the number of sig figs in all your numbers. The number with the fewest sig figs determines the number of sig figs in your answer. For instance, 13.91 times 23.3. When you multiply it, you get 324.103. Next, you want to count the sig figs of your question. This one has 4 sig figs. This one has 3 sig figs. That means your answer needs to have 3 sig figs. So you would take 324. The next digit is a 1, which means that you keep it as 324. Now you will see some odd examples here that it's a little tricky to figure out the sig figs. So if you do 235 times 3.2, for instance, when you put that in your calculator, you get 752. However, look at the sig figs. 235 has 3 sig figs, while 3.2 has 2 sig figs. That means my answer needs to have 2 sig figs. You're going to assume that there's no decimal point on these. So, 752, you need 2 sig figs. You want to round to the nearest whole number. So we're going to go 75. The next digit for rounding will be 750. If that 2 was, say, a 757, you'd go up to 760. So in this case, you do not want your ones place digit. Okay? Alright, class, if there's any other questions about your sig figs, feel free to write a comment down below or send me an email at kaminskyl@hayescisd.net.